This conference will now be recorded.
So please see my screen. So let me know once you're able to see my screen, and also I'll be opening your Jupyter notebook today. Please follow the steps how to open your Jupyter notebook. How to open your Jupyter notebook. Are you all able to see my screen? Okay. So just go to your start button and type it as Jupyter. Jupyter. Jupyter notebook. This is one way, or else you can directly go to Anaconda Navigator and open. Another way is to open using Anaconda Navigator, or else directly type it as Jupyter Notebook on your start button. So you'll be able to get a window like this. Once it loads, you'll be getting your Jupyter Web Interactive page. And it takes some time, 1 to 2 minutes of time to load your Jupyter Notebook. So it is taking time to load your libraries. Once it loads, you'll be getting an Jupyter Web Interactive page. Meanwhile, I'll try to open Anaconda Navigator as well. I've just gone through some of your assignments, but Debanshu has done correctly. I've just checked 2 to 3 people today. Debanshu's answers are correct. I need to check it out. And Rakesh, your first question, you have done most of them wrong with respect to identifying the data types. No, why it is taking a long time. So let me just open Jupyter Notebook once again. Jupyter Notebook. See, this is your Anaconda Navigator. Directly, you can click on this Jupyter Notebook as well. There's a button called as Launch. If you just click on that, you'll be able to launch your notebook. This is another way to open your Jupyter Notebook. See, Jupyter Notebook has been launched here. Local host, you're able to see here. So this is nothing but your Jupyter Web Interactive page. Now, directly click on this new button, click on Python 3, or else you can directly go to your path wherever there is a file. You can select from there also, but as of now, I'm going to my desktop. In desktop, I saved my Jupyter Python notebook files, so I'm going to open it from here. Python codes, Jupyter files. I'm opening this. This is my file. You do not have to worry about this because until and unless you type it and you save it, you'll not be able to get these files. See, now your Jupyter notebook will be like this. Generally, it will be like this. You can type your algorithms here and you can execute it, but let me explain you with respect to this one. Jupyter notebook, it's still opening. That simple linear regression file is opening.
Yogesh,
Yes,
regarding in Jupyter, the file when you say any file you save, no, it should be under the root directory only, or I can put in the D drive also. Can put it.
you can put anywhere in your local system. You can put a desktop, you can put in your C drive, D drive, E drive, whichever drive you have, you can put it.
But when you go to the file files, no, I cannot see the D drive. No,
Why you cannot see?
can you see a D drive? Can you from your screen?
See, I don't have D drive in my system. Okay,
But generally,
so
we won't see the D drive
okay,
actually.
fine. See here, you're able to see my screen, right?
Yeah,
See,
but it's all
desktop, documents, downloads, favorites, wherever you want, you can save your file.
these all coming from the system, the user
Yeah,
profile,
yes,
not from
user
the
profile.
drive actually, not from the
Yeah, not
drive.
from the drive, but you can save it. You can save it. See,
Because
I don't have.
I tried save
I
the
show you.
file in the D drive. I couldn't open the
Uh-huh.
file from the on Jupyter actually
You will
because
be
I
able to
couldn't see
open
the
it.
D. I couldn't see any D drive actually.
Okay, I'll just show you. I'll just show you.
Uh, actually, Yogesh, I think we need to upload over there in that.
Yeah, you need to upload it. That is what.
Yeah, after uploading, only be able to see here in the list.
Yes, we need to upload it and then only we'll be able to see it, right?
Yeah.
Yes. See, if you click on this button, file, open. See, you can go to your desktop or else you can go to any of your path from here. For example, let me just show you. I have saved it in my desktop itself because I don't have any other folders. See, I'm default in this. I can go to downloads, favorites, links, music. OneDrive also I can open. See, instead of opening anything else, I'm opening it my OneDrive. You're able to see?
Yeah, because all is configured to the user profile. That's why you're able
Yes.
to open to this folders. But if you go to the D drive, E drive, I couldn't map to this Jupyter.
Or else directly put it in some if users folder or downloads folder, and you can create one desktop. You
Yeah,
can create one folder, right? That also you can do.
yeah, yeah. That's why you can do it. We can do that thing.
Yes. Okay, this is your linear regression. So this is your simple linear regression. Yeah, if you want, you can open. If you want, you can open. That is also possible. See, yeah, next to new button there is upload button. That also you can do. See here, upload. This is what. If you want to open it up from your local system, you can see I don't have any other drive here. So if you click on this, are you able to see, Satish?
Yeah.
See, I don't have any other drive. I can go to this thing. and I don't have any other this thing, so that's the reason I'm not able to see D drive, E drive, but you can download it from here, or wherever the path you're having, you can download it from there.
Okay.
Now, coming to simple linear regression, see, if I'm writing it as code, it will take it as hash symbol will be taken as comment section. But if I change it to markdown, I want to do the documentation here in this doc code itself. So if I use this single hash, and if I write anything, it will be your heading. If I add two hash symbol, it will be a subheading like this. If you want to reduce the size, again, if you want, you can do like this. See, for example, I'll add like this, 4 symbol. See, 5 symbol, 6 symbol. See, until 6, it is taking the size of your this thing. Simply I'll write it as Python. Simply I'll write it as Python, and see, that should be in your markdown. If you're writing it as in code, it will become as comment section. So if you want to do the documentation part as your headings, use it as markdown. Just after typing anything in a markdown, just type it as shift enter, execute it. See, after you execute it, this becomes your heading, subheading, title, or like this. Now, when it comes to your RStudio, there is something called as packages. There is something called as packages. Hope you remember, I guess. So if you go to tools, and if you click on install packages, you'll be able to type the packages names here, package name, multiple packages here, and you can click on install. But now in your Python, you don't have anything like that. So you need to use a keyword called as import. Import is a keyword, and there are some of the libraries, default libraries you need to install. So this is one of the library which is used for your data analysis. That name is called as your pandas, and this is used for your n dimension array. You can call it as numpy. So this is nothing but your keyword called as import. So if you want to import a library, if you want to install a library in your Python Jupyter notebook, you should use import keyword followed by library name. These are your library names: pandas, numpy, matplotlib.pyplot, and as pd. As np is nothing but you are giving the short names for this pandas, numpy, and matplotlib.pyplot as plt. You can see, if you don't use this optional part, this is your optional part. If you don't use this also it will work, but the thing is, every time you should write it as pandas dot some function, numpy dot some function, matplotlib dot pyplot as some function. So that's the reason. In order to avoid all those things, you can give a short aliasing called as pd, numpy, plt. That's it. See, and also this is very case sensitive. If you just do one small mistake, like instead of typing it as pandas, if you type panda and if you execute it, it will throw an error saying that the module named pandas is not available. Panda is, see, no module named called panda, so you should type it as pandas. Now I'm going to execute it. See, once I execute, it has successfully executed and it has moved to your next cell here. So this is used for your data visualization. This matplotlib.pyplot is a library which is used for your plots, like your scatter plot, histogram, bar plot, box plot, all those things. But when it comes to your percentage matplotlib inline, this is your function. See, this is your sub package, I can call it as. So if you use this line, you'll be able to see your plots in the same Jupyter notebook. That is the reason I'm going to use this. This is optional and this is also optional. These two are optionals, so if you want, you can use it. And why this particular line is used? Filter of warnings, right? Suppose if you run some algorithms, you might get some warnings. If you don't want to see those warnings in your Python, you can use warnings library, and you need to import that. Import warnings. Under that warnings, there is a function called as filter warnings. And pass the parameter as ignore. If you do this, whatever the warnings that will be generated from your code, that will be ignored. So there is a package called as warnings, and there is a function called as filter warnings. So don't get confused. If I'm telling it as packages or libraries, it is one and the same, because in your R we call it as packages, in your Python we call it as libraries. Clear for everyone? Now I'm going to execute this line also, filtering of warnings. Now here, coming to this line of code, there is a function called as read underscore CSV, read underscore CSV, PD. PD is nothing but your pandas. So this read underscore CSV is a function which is available in your pandas library, and you can give the path here. You can give your path here. See, this matplotlib inline is nothing but if you want to display your plots in the same Jupyter notebook, you can use this, Neha. That's it, nothing else. If you don't use also, it will work sometime, but latest version it is working. But if suppose if they ask you, hey, what do you mean by this percentage matplotlib inline does, you can tell them that if I want to visualize my plots in same Jupyter notebook, I'm going to use this matplotlib inline function.
Is it library MATLAB
Yes,
body?
yes, I've written here. Matplotlib is your library, and this inline is a keyword.
No, we can use it the plot inline, no, instead of,
Hmm?
because a MATLAB lib you already
So
alias with
that
the
is your mat. No, no.
PLB.
See here, what I've aliased it. I've aliased entire thing. Matplotlib.pyplot I've aliased, not just matplotlib.
So this is different
Yeah,
library.
that is
Total.
different. Yes. Okay. Coming to this line of code, I'm using a read underscore CSV function, which is a part of your pandas library, and I'm giving the path where my local path is been storing the CSV file. CSV file. I'm going to use this. So I've written something here. I'm going to see. I'm going to comment it. I'm going to comment it, and here you need to pass your path. You need to pass your path. And at end, I've given the file name called as wc-at.csv, and I'm storing it in a variable called as wc80. wc80. I'm going to store this line of code. See, I'm executing this. Once you execute this, and if you want to see what is there in your file, you can add one cell above this, and you can type it as wc80. If you type this wc80, you'll be able to see. See, 1 second, let me delete this line here. See, if I just execute this WC80, what is this WC80? Can anyone tell me what is this WC80? It is nothing but your CSV file, the library which I have, the variable which I have stored the data set, the data set. So if I give this WC80, see, it will display all the records, whatever there is in my data set, whatever there in my data set. 109 rows into 2 columns. Sorry, one sec. It is answer that it will display your entire. 1 second, dragged. See, it is displaying all the 109 records, whatever there in your data set. It is having how many rows? It is having, you can see it is 109 rows into 2 columns. So what is the function do we use in your R? If I want to see the dimension in your R Studio, what is the function? It is your dim, dim.
Dim.
So when it comes to your Python, we can use that also here. So exactly, it is not dimension dim, it is something. Can anyone tell me what is the function to see your dimension in your Python? So I don't want to display all this 109 records because it is taking huge space. So what I'll do is, instead of writing it as WC80, I'm going to write it as only top 5 records. What is the top 5 function? You can use just head function or tail function. Head, I'm going to write it, and I'm going to give this, execute this instead of writing all these records. See, I'm able to see only 5 records. 5 records. Yes. So now I want to see the dimension of the data set. I want to see the dimension of this data set by using a function called as shape. So WC80 is nothing but your file name or the data set name. Shape is a keyword. Shape is a keyword in your Python. If you type that shape, it will give you the total number of rows and columns. You can see it is 109 rows and 2 columns. You're able to see here? In your this thing, I used to write like this, WC80. This is your R Studio. Here you should write it as WC80. Instead of dim, you should use keyword called as shape. It will give you the dimension of your data set. Now, if you want to see the just the column names, like this is your column names, right? If you want to just see your column names, you can use this function called as, not a function, it is just a keyword. So the file name followed by columns, file name dot columns. If you specify, it will display your column names here. Let me try to execute this line of code. See, it will display your waste and 80. I showed you Rakesh. If you just run that add function, it will display your first 5 records. See here, Rakesh. WC80.add function, if I execute it, it will display only the first 5 records. That's it, nothing else. First 5 records. If you specify, I want to see only top 3 records, you can specify 3 records. 3 records. If you want to specify, if you want to see last 5 records, you can use a function called as tail, T-A-I-L. So I want to see the last 3 records. I can give it as like this. See, totally I'm having 109 records, 109 records, and it will display your as 106, 107, and 108 because it starts from 0, 1, 2. 0, 1, 2. Got it, Rakesh? Okay. So now until this point, please note down the notes on the functions and the keywords until this point. Whatever we have executed until this point, from your pandas until your shape function and your columns function. Write down this until this point. Okay, now let us move on to the next this thing. I want to plot histogram for one column or box plot. I'll just show you for a, I've already explained you how to plot your histogram, how to plot your box plot. I'm just showing for understanding purpose here. So now you can see here there's a function called as hist. Hist is a function which is a part of your matplotlib.pyplot as PLT I've written, right? So it is a part of your PLT. So ist is a function. I'm writing it like this, and I want to plot for which column. So it is should be file name dot column name. So if I use this, I'm going to get this histogram. So if you want to visualize your histogram, you can use this plt dot show function. Plt dot show function. Plt dot show function. So if I run this line of code, you'll be able to see your histogram. See here, histogram has been. Now, yes, Debanshu. Okay, tried when I tried to find that my R Studio and Python Anaconda were automatically deleted. Is it because of Windows Firewall or something? Yes, it is because of Windows Firewall. I told you don't try to install R Studio from Anaconda Navigator. That is the reason in the first day itself. That is the reason I showed you separately install your R Studio. Separately install your R Studio, Devanshu. Don't launch it from Anaconda Navigator. Don't launch it from Anaconda Navigator. Now, see, this is your histogram. So this is a function to use your plot your histogram. Then it shouldn't be a problem. Then there might be some other problem from your system wise, I guess. I don't think so that should be a problem because I've already installed all those things in my personal laptop as well as my other laptops and desktops as well. Okay, so now I want to plot my box plot. So there is a function called as box plot, which is also a part of your matplotlib. So I've written it as plt.boxplot, and here I can specify my file name dot column name. File name dot column name. So you'll be able to get it as plt dot show. You'll be able to get your box plot. Along with that, you'll be able to get your box plot.
Yogesh, we don't have here attach function.
No, if that would have been there, then no need of writing this PLT for C for this, especially for this libraries only. There is no import. Apart from your import, you should write for each and every line of code. You have to write your library names, and also you should specify your file names. File names. And see, this is your box plot. This is your box plot. If you don't want your box plot in this way, you want to plot it in your horizontal way, you should use a keyword called as vert is equal to false. If you use this vert is equal to false, rather than getting it in your vertical box plot, you'll be getting your horizontal box plot. Horizontal box plot. See, that's it. There is no rocket science between your vertical and your horizontal box plot. I already explained you all these things. So let us come to your scatter plot. Let us come to your scatter plot. See, PLT. So what is the function to plot your scatter plot in your RStudio? RStudio, Rakesh or Bharat?
Just plot only.
Hmm?
Just plot PLOT.
It is just your plot. It is just your plot function. So in your Python also, this is just a plot function, but followed by your which library? Followed by the library. So plt.plot, and here you should specify plt.plot, and you can specify it as x comma y. X is nothing but your file name dot x variable, file name dot y variable. And what is this bo? Can anyone tell me what is this bo? Can anyone tell me what is this bo? Okay, I'm going to remove this bo. If I execute it, what will be your answer? Box. What box? You're getting it as like this. If you remove that, you're getting it like this. But you're not getting your circles, right? So that is the reason. If you want, I can write it as, see, let me just write it in this way. Box points. You cannot, yeah, points you can tell it as, what is this
Da-
BO?
Data points.
Yeah, what does this BO stands for? B stands for. I'll change it to RO. Or I'll change it to GO. See the difference now. I'm going to execute this line of code. Yes, it is nothing but your color circles you are getting, right? Circles. So you'll be getting your blue color circles, red color circles, green color circles like this. That's it. So this is your plt.plot is a function. You can pass your x comma y or y comma x provided by go. So if I write it as like this, if I write it as plus like this, what will be your answer? If I execute this line of code, you're able to see instead of circles, I'm getting it as plus mark. Plus, that is the difference. That's the difference. Let me put it as usual as RO. I'll put it. RO, I'm going to put. See, red color circles. Is it moderate or strong positive or weak positive or what it is? Yesterday we have discussed.
Moderate positive.
Yes, yesterday we have discussed it is your moderate positive. Moderate positive because it is slightly loosely spread as the scattered or the data points are loosely scattered. Now, yes, moderate positive. So now coming to that here, I'm keeping it as same as it is. I'm adding two more optional lines here and I'm putting it as x axis label and y axis label. plt.x label, plt.y label. X label, y label is a function under your matplotlib.pyplot, and I'm giving whatever the title I want on my x axis and your y axis. That's it. If I execute this, I'll change it to or O. So if I'm executing it, you'll be able to see that there is 80 on your y-axis, x-axis is your waist. So after your plot, what did we do yesterday? After checking your scatter plot, what is the next line we did?
Histogram.
Histogram. Wrong. Histogram yesterday and I explained you, right? Yes, we need to check your correlation, right?
Yeah.
Correlation coefficient, right? So that small r value. How much we got yesterday? Small r value?
0.8.
0.81, right? Something.
Yeah.
So that is your multiple r squared value, Devanshu. So that is your multiple r squared value when we built our model, right? Still, we are identifying your correlation coefficient, r. So you are talking about your r square. Got it? Just recall yesterday's session. So now I want to calculate my correlation coefficient. See here. So correlation value between x and y. So in your R Studio, I wrote it like this, x comma y. But here you can write it in this way, or else you can write it in this way. If you want to write it in this format, you should use y dot core function. Here it is your core, C-O-R-R, and here it should be x. Y dot core of x, or you can write it as x dot core of y. Whichever format you write, you're going to get, but this is a function for your calculating your correlation coefficient in your Python. In your R, it is just COR, here it is CORR, followed by this particular syntax. So if I'm going to execute this line of code, I'm going to get the value as 0.81. 0.81. So yesterday also we got same value, but here it is with respect to the values are with respect to decimal, everything is being displayed. So apart from that, if you want to write it in another way, there is something called as core coefficient is a function. CORR COEF is a function which is from your NumPy library, So I'm writing it as np.corrcoef, and I can pass it as x comma y here itself, x comma y here itself. And if I run that, I'm going to get in it like this: your waste, your fat column, your waste, your fat column. You'll be getting it in your matrix format. If I use this syntax, I'm going to get it in this format. Between waste and waste, it will be 1. Between fat and fat, it will be 1. And between waste and fat, it will be 0.81. And here it will be 0.81. Because you're having only one input and one output. So this is another format to calculate your correlation coefficient. This is nothing but your function. This is nothing but your library name. This is nothing but your y. This is nothing but your x. Either you can write it as y comma x or x comma y. So if I execute this, I'm going to get it in this format. Clear?
Yogesh, the line number 21,
Mm-hmm.
we didn't mention any the library name here, no?
Yeah, I did not mention any library. That is the reason. Here, see, this is under your base library. This is under your NumPy. This is under your NumPy. So let me try to remove this NP and see whether this base library has been updated or not, just for confirmation. See, if I remove that NP, you are not able to plot it because that is not available still in your base library. So CORR COAF is not defined. So that is the reason I'm using this NP. Clear for everyone? So note down until this point from your scatter plot, correlation function, just note it down. Remember, tomorrow will be a practical session. So I may ask anyone just to get confirmation about, at least you remember the function names. Now, after checking your correlation coefficient and your scatter plot, what do you do? What did we do? Next, we try to build your linear regression. What is the function to build your linear regression model in R? Bharat, Rakesh. LM. It is LM. LM stands for what? Full form. Full form of LM. Come on, Rakesh. Bharat. Ratnesh.
Linear model.
Yes, it's your linear model. Linear model. So now the next is we are going to implement your linear regression on this data set. Linear regression on this data set. For importing your linear regression, we have some libraries. We need to import it, and then we need to implement your linear regression. For implementation of your linear regression model, you need to use a library called as statsmodels.formula.api. This is your library. Statsmodels.formula.api is your linear regression models library, and I'm giving it a small name as alias name as SMF. SMF. Now, after this, you need to implement. So in your lm function in your R, here you can use a function called as OLS in your Python. This is in your R, this is in your Python. So this full form of this OLS is nothing but ordinary least squares method. Ordinary least squares is the full form of your OLS. This OLS is a function which is available under your statsmodels.formula.api smf.ols. And same, so yesterday we wrote it like this: lmy tilde x. Here you should write it as OLS followed by your library name. That should be mandatory. smf.ols. Within double quotes you should write your y tilde operator x. Close it. And also you should specify the file name here. There also in your R also you can specify what is your file name. Data is equal to wcat, but I did not show because this is default. But in your Python you should specify data is equal to wcat dot fit. So you're fitting your linear regression model on this data set, on this input and your output by using a function called as OLS. So this fit is a function, means it is fitting your linear regression line or linear regression model on this OLS based on your input and your output on this particular data set called as WC80. So you should write it in this format. Suppose if I remove this WT data is equal to WC80, I'm going to execute it. See, SMF is not defined because I have not even run this also still. So let me run this line. After running this line, I'm going to execute this line. See, it is saying that data is missing. It cannot identify from where do we get this AT and waste. So that is the reason you should specify data is equal to your file name. Now if I run this line of code, it is going to be executed. And the variable, the linear regression model, whatever I built, I have stored it in a variable called as model. So what is your model name? Model name is nothing but model. Now you want to see what type of model I have built. Just use a function called as type. Type is a function and pass your model name here. You will be getting what type of model have you built. So now you can see here, if I'm going to execute this line, I'm going to get it as stats models dot regression dot linear model. So this is your linear regression model you have built using your stats models library. This is your main library, this is your sub libraries. Okay, so this is your stats models dot regression dot linear model. That has been your type of your model, that the model whatever we have built and stored it in a variable called as model. Now if you want to see your output of your model, yesterday we wrote it as summary of your model name like this. So today either you can go like this, model.summary, or if you just want to see what is beta naught and beta 1, you can just use a function called as keyword called as params. So now Bharat, can you tell me what it is? What is this?
It's the model that we have created.
It is the model name that we have created here, line number 29. Yeah. So this is a keyword. Params is a keyword. If you use this params, it will only give you the coefficients, that is your beta naught and beta 1. If you just want to see beta naught and beta 1 values, you can use a keyword called as params. These are also called as your parameters. Yes. These are also called as your parameters or your coefficients or estimates. Correct, Debanshu? So see here, yesterday we got same minus 215.98, 1488, and your beta 1 is nothing but your 3.45. If I'm going to execute this, I'm going to get the same values as your parameters. If you just want to see your beta naught and beta 1, you can execute this. See here. Now, see this. If I run this function called a summary function with your final model name, model.summary function, you're going to get your result of your linear regression model. Linear regression model. See, you can see there are some other values also, but whatever we need is, we need only your coefficients. Your coefficients, see here. Intercept and your slope, that is nothing but your beta naught and your beta 1, and also you should see with respect to your p value. So your p value should be always less than 0.05. P value should be less than 0.05. So yesterday we got some 3 stars, right, in your RStudio. Hope you remember. So in your Python you will not get these stars and all. You should see this particular value, that is your p value. This is your p value, and these are nothing but your coefficients. These are nothing but your beta naught and beta 1. And you can see here are just multiple R squared value is how much? Multiple R squared value is how much? Yesterday how much we got? Multiple R squared value. Yes, 0.67. Now how much we got? Same multiple R squared value, we got it as 0.67. So this is your 67% accuracy of your model. 67% accuracy of your model. It says that dependent variable is nothing but your fat. Fat is nothing but your output variable, and you can say that it is your OLS, ordinary least squares method, and you can see the time 5th September 2018. Just now I ran this. This is your time. So this is how, sorry, I did not run it now, I guess. So let me just execute it. Let me see. Now whatever the time I've run, that time also will be there, and adjusted R squared value, multiple R squared value, number of observations, residuals, AIC, BIC. So this AIC I show you when I implement your multiple linear regression. This one and this one I'm going to explain you at that point of time. Apart from that, you also see that your beta naught and beta 1. And what are these two values? What are these two values? Yesterday we got these values. What are these two? Use your common sense at least now.
Upper limit and the lower limit of.
Yeah, lower limit. What is the function yesterday we used? Yeah, upper range and lower range, beta naught and beta 1, beta naught and beta 1. What is the function we used yesterday? We used one function, right, for this line. What it is? Anyone remembers? Yes, it is nothing but your conf int. It is not predict, it is your conf int. It is your conf int, Ranjini. CONFINT. If you use that function and if you pass your model name, comma, level is equal to 0.95 with respect to 95% confidence interval, you got your beta naught and beta 1 for lower range, beta naught and beta 1 for your upper range. So if you directly run your model.summary function in your Python, you're going to get that also in this same output. That also in your same output. Or else if you want to get it separately, also you can use a function called as conf underscore int. Conf underscore int. Let me show you that also. Let me show you that also. See here. Here I am passing model dot conf underscore int. Conf underscore int. Type it as, if you want 95% confidence interval, out of 100% minus 95% is how much? It is your 5%. You should specify in your parenthesis it is 0.05. For 95% confidence interval, you should specify your 0.05. 100% minus 95 is nothing but 5%. If you want to do it for 90% confidence interval, you should specify as how much here. What should be value for 90%
Point
confidence interval?
0.10.
Point,
0.10.
0.10.
At 0.10, if you specify, you are going to get it as confidence interval for your 90%.
90%.
90%. So let me run this. You'll be getting same values here also. So let me execute this line of code. Got it? It is same as your this is your lower range, this is your upper range. Minus 172, minus 172, 3.924, 3.924, and minus 259, 2.99, 2.99. Got it? Write down this linear regression until your confident functions. Whatever the syntax I've written, just note down this. Yes. They might not ask you the libraries exactly, the sub libraries and all, but they might ask you some functions. Probably they might not ask you 90%, they will not ask you 10% probability. It depends on who is your interviewer, Ratnesh. At least you should remember pandas, numpy, stats models, matplotlib, pyplot, scikit-learn, all those things. At least 5 to 10 libraries. If you remember, it's more than enough. Okay, is it done? Is it done? Okay, Now you want to see your predicted values for your values. Predicted values for your output. You are having your actual value, you want to see your predicted values. So you can use a function called as predict. Predict is a function and you can specify it as WCAT is nothing but your data set name, and this is your model name. This is your model name. After this, you can specify it in a variable called as spread or whatever. This is just a variable name. I can put it as y spread or anything. And so let me just run this line of code. I'm just putting it into comment section. I'm just going to execute it. I'm just going to execute this and you will be able to see your output. You'll be able to see your predicted values, but now the variable is stored in a variable called as pred. So if you want to see that, you can see pred. You can remove this and you can just run this. You are able to get your predicted values for first one, second one, third one, fourth one, fifth one, sixth one, seventh one, like this. Write down this. Write down this point. Write down this particular function called as predict. So what is the function in your R Studio for predicting your values?
There also it is predict.
Yes, there also it is your predict. But here you should specify it as model name first and then predict function along with your data set name. It is your predict. So now after this you can, so I'm not going to show your predict function, that is complicated for with respect to your lower range and upper range in your this thing. I'm going to show that in your multiple linear regression. So this is your actual predicted values, that is nothing but your fitted values. Now if you want to compare this with your original values, that is your actual values, you can compare, and if you take the difference between those two, you're going to get your error. You're going to get your error. So once I explain you that multiple linear regression, I'll show you how to get your upper limit and your lower limit for this. Upper limit and your lower limit for the particular records. Okay, I've given it as tissue, fat. Now, so what I'll do is I'm going to show you your transformation now. I'm going to show you, I want to increase my accuracy of my model from, what do you mean by that, Ram? What do you mean by any function to find error?
Like, yeah, we usually the predicted value and actual value we find, right? So we minus,
Directly
we
there is
find the difference
no,
between this.
in this directly there is no like that. I'll be showing that also in one scikit-learn. I'll show you, but directly there is no function.
Okay, fine.
There's something called as your predict function when it comes to your this thing scikit-learn. I'll show you that also, but not here. Now, so I want to implement, or I want to do transformation. Instead of getting 67%, I should increase it to 70% or 75%, whatever it is. So I'm going to do transformation. So first I'll be showing you with respect to your transformation, that is your log transformation. For log transformation, there is This, see. But for log transformation, if you directly use log of x, it will not work because this log is a function under your numpy library. Numpy library. So here I've written it as np.log of waste. np.log of waste. Got it? So np is your library name, that is numpy. Dot log is a function, and here you can pass it as your waste data or your input, and you can see everything is same. Everything is same apart from this part. And here I am giving this one. Here I am giving the same fit function smf.ols model 2. And if you don't give this, for example, consider that you don't specify this np, you think that this log is already available. So what you do is you'll directly think that, and you're going to execute it. If you execute it, it will never show your answer. It will show as name log is not defined. Name log is not defined, because you should know that np is a part of your log is a function which is a part of your numpy library. Sorry, numpy is a library which is a part of your log function, for your log function. Now if I write this and if I execute it, I'm going to get your model 2. Now if you want to see your model 2 parameters, you can use model 2 dot params. Model 2 dot params, and you will be able to get your model 2 parameters just as your beta naught and your beta 1. If you want to see the entire result, again there's a function called as summary function. Summary function. So now I'm going to run this line. You can see that it might have been slightly increased the accuracy rate from 67% to 67.5%. Now, if I don't want to use it as 67.5%, I can go for next regression. That is your next model, taking as your exponential model. Exponential model. I'm going to directly jump into that part. I am not going to run again confidence interval, all those things. I'm going to jump into my, sorry, here it is. This one. See, I've already written this as your log of waste, and this is what I'm going to do is exponential transformation. I'm going to apply my log function on my output, and your input is as it is. Your input is as it is. I'm going to apply log function on your output, that is called as your exponential transformation. So again, if you use, you should use it as np.log, because this log function itself is a sub library of your, sorry, log function itself is under a library called as numpy. Under a library called as numpy.
So Yogesh, you are using the two libraries, no? SMF and
Yes,
NP.
yes. This is SMF is for your OLS function. This NP is for your log function. NP is for your log function. See, I've run this, and now if I see these parameters of this function, I'm going to get these three. This as your beta naught, and this as your beta 1. So if you want to see the summary of your output, you can just run this model3.summary function. You can give any model name. You can give any model name. See, this is one way to perform your linear regression by using your stats models.formula.api. Why I'm using this method is because in your R programming also you use similar format, y tilde x operator. So here also you are using OLS just followed by your library name. Apart from this, you can also use using scikit-learn, and also apart from that you can use multiple methods are there to implement your linear regression, but if you know R and Python, it is easy to remember. So that's the reason I'm giving it as smf.ols part. This one I'm explaining with respect to stats models. Stats models. See, it has increased to 70%. It has increased to 70%. You can see your p-value is also significant. You can see this is your beta naught and beta 1. Here also we got the same thing. Same is here. Same as here. Okay, R value from the log transformation. One sec. Let me scroll up. You mean to say R square value, right? It is not R value. It is your R square value. How much you got from your R value, R square value for your log transformation? You can see here. See Manju here. I've used log transformation. You got it as 67.5%. Yesterday we discussed, right? Got it, Manju? Your answer for this log transformation. This is your log transformation. Just now I explained you about your exponential transformation using your this point, this particular same parameters, coefficient, summary, confident. You can use it for your N transformation to see your results. You can see your results. And this is your predicted values. These are your predicted values. Any questions here? Any questions with respect to your Python functions and your this thing? When I implement your multiple linear regression, I'm going to explain you some more extra functions as well. So as this is your first linear regression model, this is your first prediction model, I'm keeping it as simple as anyone can understand. If you want to give quadratic model, again you can do this also. You are just taking your square of your waist and you're putting here, and you can use this waist square plus waist, and then you can implement that also. That also is possible. That also is possible. This is called as your quadratic model. First, what you are doing is y tilde x is there, right? Here you are not taking it as x. First, you are creating one x square equal to x1, and then while building your model, you are passing it as y tilde operator x plus x square. That is your x1. X plus x1 you are writing. See here, waist into waist, I am creating one variable called as waist square. Waist square. While building your model, I am specifying it as ordinary least regression AT is your output, fat is your output, waste is your normal variable, plus waste underscore square is your square variable, and I'm going to build one more model. I'm going to build one more transformation model. So let me just try to see whether it is executing and it is giving a best model or not. Best model or not. What is the accuracy rate? See, again, it has not increased to a greater extent. It has just given 67.8%. Earlier it was better. See, you created one extra variable called as waste square. So then also, see, these two are significant. See, these two are less than 0.05, and this one, if you see, it is greater than 0.05. You're able to see the difference? Bharat, Rakesh, Debanshu, Imran, Lahari, Mega. You're able to see this difference. We created one variable called as waste square, right? So this waste square, you are getting it as p value greater than 0.110, means it is greater than your 0.05. So it indicates that this waste square variable is not significant. Got it, Bharat?
Yes, sir.
Mega, Lahari. So you should also see, you should not only see your parameters, you should see along with your p-value. If this is significant, then your model would have been increased. Even though you are adding your variable, if it is not significant, it is not making any impact on your model accuracy rate. So now take down some important questions when it comes to your linear regression. Important questions with respect to linear regression. 2 to 3 questions they might ask you. Interview. If you tell them that I have been implemented linear regression, so they might ask you, so when or in what scenario, are you going to implement simple or not simple linear regression? Be prepared with your answers tomorrow. I'm going to ask anybody from the group. When or in what scenario are you going to implement linear regression? First question, they might ask you. Second question, what is linear regression equation? Can you explain me linear regression equation? Second question. What is linear regression equation? Third question, very important question. How do you measure the performance of linear regression model? 3 questions. When or what scenario are you going to implement linear regression? And can you explain me linear regression equation? Then how do you measure the performance of your linear regression model? Yeah, tomorrow I'm going to ask you all these answers, no worries. And fourth question, what do you mean by correlation analysis? What do you mean by correlation analysis? Fourth question. Write down these questions. I'm going to rub out these questions and I'm going to give you 1 or 2 more extra questions. See, if you are noting down, just put an heading that interview questions with respect to linear regression and correlation analysis, and write down this type of questions. Is it done? 4 questions, is it done? Okay. Now, fifth question. Can you explain me about multiple R squared value? Multiple R squared value, this one. Multiple R squared value. These are the 5 questions you should explain me tomorrow. Along with your coding part, I'm going to ask you some of the function names, some of your interview questions. Whatever I have taught in the class, I'm going to ask you the questions. Whomever I'm going to pick, make sure that you have your headphones ready. Don't tell that mic is not working, that is not working. If it is not working, you will be under loss. Remember that. Remember that. Okay, if you are not able to talk, just type your answers. Private chat, on private chat. Okay, so after tomorrow's session, we are going to jump into a technique called as multiple linear regression. So this is also interesting. Apart from this, we are having some around 15-20 minutes theory. Along with this theory, we are going to do implementation of a business case, and then that will be in your R and Python as well. R and Python as well. Clear for everyone? Tomorrow again we'll connect around same time, 7:30 p.m. and before class starts, be ready with your Python Jupyter notebook and be ready with your R programming. I'm going to ask you some functions, whatever we have discussed till date. You should tell me the values. You should tell me the values. Yeah, I'll be sharing that, Satish, as well. I'll be sharing that. Okay, thank you all. Good night.